Alright, so in today's video I'm going to give you just a very quick update on my motion controller project. Hopefully you would have seen my previous video. I showed you this guy here. This is my motion controller version 1. But just to explain for those of you that didn't see that video, the goal here is to make a motion controller very similar to the DJI motion controller. But this is going to be one that's designed very much for sort of like fixed wing drones using the ERS protocol. And yeah, basically the gist is, you use motion controls like rotate left, rotate right, up, down to, control your drone. In my previous video, I demoed me using this one here, the version 1 controller, and it was working very well. I demoed me using it to fly my He-Wing T1 fixed wing drone very successfully. All worked very, very well. But on the version 1 controller, the way it was working at that point is it had to be connected to my transmitter, to my Radiomaster pocket radio via a cable. And that's because the version 1 didn't have any ability to transmit by itself. It didn't have any sort of radio gear built into it. So it had to rely on my transmitter, which obviously is a bit pointless. But it was what I needed at the time. So anyway, since then, I have built a new one. This is the version 2 controller. Hopefully you can see it's a very similar looking device. The shape's a little bit different. It's very slightly bigger, but it's ultimately the same kind of form factor, with like a throttle and some buttons and stuff. But the big difference with this new version 2 motion controller is this one now has transmission capabilities. It's got a built-in module. I went ahead and I bought a Radiomaster Ranger Nano ELRS module, which I then stripped down. I was able to shoehorn inside this new controller. And then after quite a lot of sort of work, I was then able to integrate it with the microcontroller in here, get the code talking, and then allow this new motion controller to be a standalone device so that I can then, fly one of my fixed wing drones without my transmitter or no cables. I can just, use this to fly my fixed wing drones. I will put some footage on the screen now because I know that that's mostly what you guys want to see. You want to see, footage of me actually using this and actually flying it. So I'll put it on the screen now, and you can see that this is working very, very well. And whilst you're sort of watching that, I'll just talk to you a little bit about the details and the next stages in the project. So what have I got working? So obviously I've got the microcontroller inside talking to the transmission module and obviously broadcasting, hence obviously you've seen this footage of me controlling the drone, and it's obviously working very, very well. It took a little while to kind of figure out exactly what kind of communication protocol is being used and get the right kind of like speed of communication and stuff like that. It's all very complicated, but I've managed to figure that out, and obviously that's the most important bit. Allows me to obviously use the controller to actually control my drone. That's working very well. What I don't yet have working though is kind of like two-way communication between the microcontroller and the Ranger Nano. So basically I can't program or customize any of the settings on the Ranger Nano yet. So like at the moment the Ranger Nano it's on its default settings, which is 100 milliwatt transmission power, 250 megahertz transmission packet rate, whatever it is. Now obviously those are things that you can normally customize. You can normally put the power output higher. I think this can do 1 watt, I think. And normally you do that via the Lewis skip on your radio. I haven't yet fully figured out how to do that with this yet. I've made some progress, but I haven't fully been able to get the communication working properly. So at the moment, I can't customize any settings on the transmission module. That's something that I'm going to be working on, before I do version 3. One thing I do have working, however, is the Wi-Fi mode on the Ranger Nano. And the reason why it's important is because if you couldn't access the Wi-Fi, you wouldn't be able to access the Express LRS webpage thing where you put in your bind phrase. Obviously, you need to be able to do that because otherwise you can't bind it to any of your aircraft. But yeah, I've got that working. And the way I've got it set up is that when you power this device on, if you just push the joystick to the right at the same time you power it on, that will initiate the Wi-Fi mode. And then you can access that webpage and then do your bind phrase. So that's what I've got working so far, but obviously there's still a lot of work to do. Now, other things that have changed with this version 2 controller. So I've changed the switches. On the version 1, I had these big rocker switches, one for arm, one for return to home. They work great, but they were very big. And I don't mean externally, I mean internally. They took up a lot of space inside, which wasn't ideal. So I've replaced them now with 2 much smaller switches, 2 little momentary switches. So it's press once to activate arm, press again to deactivate arms, same for return to home. That works much better. I do very much need to add a third switch, and it's going to need to be different because I need a mode switch. You know, especially for fixed wing drones, it's very common to have different flight modes. So I need to come up with some kind of switch to do that, and it needs to be free position ideally. So it has to be different to them. And also the joystick. So same as the version 1, there's a joystick here that does left and right. That's just for yaw, because you can't do yaw with motion control properly, so you need a physical joystick. The joystick I'm using at the moment came from Amazon. It's pretty crap, and it's also very big. Again, it takes up a lot of room inside, and that's kind of dictating the size of this device actually, because that joystick's very big. If I can get a smaller joystick, or maybe like a little scroll wheel or something, I can make this whole thing a hell of a lot smaller. So that's something I'm going to be looking into doing at some point in the future. It's just some kind of smaller joystick, or I might even get rid of it. I don't know if I need it. Most of my fixed wing drones don't even use yaw. They don't have rudders. So I don't know if I need a yaw joystick. It's mostly there for quads, which I don't even really fly. I'll be interested to know your thoughts. Should I keep the capability to do yaw, or should I just get rid of it? I don't know. Let me know what you think about it. But yeah, that's something else I want to change at some point in the future. At the moment, although this is now a standalone device, you still need to plug in a battery at the bottom. I've got a little XD60 connector here. You need to connect a 3S or 4S battery to power this. Bit annoying having that hang out the bottom. I would very much like one of the future versions of this to have the battery kind of inside. So that's something I'm going to be kind of working on in the next version. And also I need some kind of like power monitoring as well. Because at the moment, if the battery runs flat, there's no way for me to know anything about that other than the controller will just turn off, which obviously is not ideal for in the middle of flying. So I need to kind of wire in some kind of like voltage monitoring. So this will give me some kind of alarm if the battery is running flat. Other things I want to work on in the future. So at the moment there's an LED on here. It's just a green LED. And at the moment it has different flashing patterns to tell you different things. Like if the aircraft is armed or disarmed, it changes how it flashes. Or if it's in Wi-Fi mode, it's a faster flash. That all works fine, but I think I'd like to replace that with an RGB LED in the next version, so we can actually have different colors. So like, green could mean everything's all good, red could mean there's a problem, or maybe the controller's disconnected from the drone. Maybe like blue could mean Wi-Fi. Just different colors for different things. I think it'd be a much more intuitive way for feedback. And also talking about feedback as well. So as I demonstrated in my previous video, this device got a little beeper in it, and it plays different tunes depending on what you're doing. Like, if you arm the aircraft or press return to home, it plays different tunes. That works fine, but I think I'd like to actually put a little speaker in this if I could, so it works the same way as an express LRS radio. So rather than just beeping tones, it'll actually say what it's doing. Obviously, if I press the arm button, it will say armed or disarmed, or if I press the return to home, it will say returning to home. I'd much rather have some actual vocal feedback. So I think that at a future point, I will try and put an actual little speaker in this rather than a little buzzer. That's something else I'm going to be working on. So yeah, lots of things that I still want to do on this, and also just the aesthetics. I want to make this look much nicer. It's very bulky at the moment. I've put no thought into the aesthetics of this yet whatsoever. I've very much been working on just making this work well. Function over form, as they say. But yeah, at some point in the future, I'd like to make this look nicer and just feel nicer in the hand as well, because it is a little bit clunky to hold. But yeah, that's all the things that I know I've got going so far. This is a big step up from the version 1, the fact it's now an independent device. And as you can see from this footage, it works very, very well. And it really is such an intuitive way to fly. So much more intuitive than using sticks on the radio. Like I said, it's a bit like a fighter jet with its joystick. It's just so intuitive. You want to go left, you just lean it left. You want to go up, you just lift it up. Very intuitive, and as you can see from the footage, you've got total control of the aircraft. It's not like shaky or anything. I've put a lot of filtering into the code of this, so handshakes don't do anything. It's a very, hopefully you can see, it's a very smooth way of flying. It's a lot of fun. One last thing I just want to explain as well, just in case anyone's interested, is you might be wondering how it is you actually launch a fixed wing drone when you've got a motion controller. Because if you think about it, as you throw your plane, it's very hard to hold your hand still. And if you don't hold your hand still, that's going to potentially make the plane, zigzag all over the place during launch, and it might crash. So the way you launch it, I did explain this in my previous video, is that the joystick is also a button. Hope you can hear that little clicky button. And that's actually doing the lock So the device got a lock on it. When you first turn the device on, it's locked, which means that no matter how much you move it, it doesn't send commands. It doesn't send any commands until you unlock it, and then obviously it does, and then at the end, you can lock it again. So the way that launching a fixed-wing drone works is you have to have launch mode enabled on the drone, which you do in iNav. I think RD Pilot's got something similar. And then all you do is you just press the arm button, you set the throttle, you then throw the drone, at which point it takes off and it immediately starts climbing. Once it's in the air, all you've then got to do is just press the unlock button, and then you've got full control of the aircraft. Works absolutely perfect. Works very well. Nice little simple system. So anyway, yeah, very, very quick little update for you on the motion controller. We now have a motion controller version 2, and there's going to be a version 3, probably a version 4. This project's going to keep me busy for quite a while. And I am aware this has been quite a short video, quite a fast little video as well. I'm really getting quite annoyed with YouTube at the moment because I put quite a lot of time and effort into my videos normally. And then I upload them and then none of you guys really see it, and it's not your fault, it's YouTube's fault. The algorithm, it just does not really support small channels, especially ones like mine where we don't post super often. We don't get rewarded for putting lots of time into our videos. We actually get punished for that. They'd rather we just churn out crap quickly, and I don't want to do that. But yeah, it does mean that I don't really feel very inspired to put maybe quite as much time into my videos at the moment. I'd rather just reel off the information to you a little bit quicker, so that's what I'm doing in this one. Yeah, just very annoying that the YouTube algorithm doesn't really sort of look after its sort of smaller channels very well. I did recently discover about the hype button down there somewhere. There's like a little hype button. Apparently, if you guys press that, it kind of tells the algorithm actually this small channel's good, support it. So if you're feeling generous and you see that hype button, I'd be very grateful if you press it. It might help or it might not. But yeah, anyway, that's a little mini rant. This is the Motorola version 2, working very well. There'll be a new video at some point in the future when I've made even more improvements and upgrades. I hope you're enjoying this video. I hope you're enjoying this little series. And yeah, run out of things to say now. So I guess I'll just see you in the next one. Cheers, guys. Bye.